Hello and welcome to the seventh and final lesson in our fourth unit, Graphing Quadratics, in our grade 10 academic math class. So this is an extension of our factored form version of a quadratic relation learning that we started in lesson number 6. We start with a recap, which basically says you can go from our standard form version of a quadratic relation, which has no brackets, y equals ax squared plus bx plus c, and you can turn it into good old factored form, y equals a bracket x minus s, x minus t, and you can do this by factoring. So in our first example, we're going to work through one where we're given something in standard form, and we are going to transition it to factored form before finding a vertex and then graphing the whole thing. So let's start. Here is our first example, y equals negative 2x squared minus 4x plus 6. So from this version of the quadratic in standard form, we have our a value, which tells us two things. It tells us there will be a vertical reflection across the x-axis. That's what the negative tells us. And 2 tells us that we have a vertical expansion by a factor of 2. So our plot pattern, our 149, will be amplified by 2. Standard form also tells us our y-intercept, which in this case is going to be plus 6. So we've got a direction of opening, we've got a plot pattern, we've got a y-intercept. We don't have a vertex yet, and we don't have any x-intercepts. So today we're going to look at how to go from that standard form to factored form, and we do it by factoring. So if we look at that, we can common factor negative 2 out of all three terms. And when we do that, we're left with x squared plus 2x minus 3. Now the contents of our bracket, once we've common factored out negative 2, is a simple trinomial, which if we remember back to factoring, it means that we want to find the thing that multiplies, maybe I'll write this in here somewhere, we want to find the thing that multiplies to negative 3, but that adds to positive 2. So when we consider those factors, the numbers that will lead us to that is plus 3 minus 1. So maybe we'll put that over here too. Plus 3 minus 1. When we multiply them, give us negative 3, and when we combine them, give us positive 2. So let's put those into the brackets. Again, each of these brackets is going to start with an x, and we put our positive 3 and our negative 1 in there. So we have gone from standard form to factored form by common factoring and then factoring a simple trinomial. Any type of factoring could be done here, however. We could also have treated this like, if it worked out that way, it might have been a difference of squares. It also might have been a tricky trinomial. So any of the types of factoring we've looked at could be relevant or applicable here. So let's get our s and t values here. Now recall that the s value is the opposite of how it appears in the bracket. So our s value is actually not a positive 3, but minus negative 3. And our t value is the opposite of how it appears. It looks like a negative 1. It's actually minus positive 1, so that's going to be a positive 1 there. So we have our two zeros, our two x-intercepts. Now we are actually going to write these out as points. So our two x-intercepts are going to be 1, 0, and negative 3, 0. And again, we determined this by once we've factored it, we look at the two values in the brackets and then consider them to be their opposites. So we've got this. Let's actually take a moment now and sketch some of this stuff onto the graph. So we have our y-intercept at plus 6. So let's get that happening. There's our y-intercept at plus 6. And we have our two x-intercepts. One of them is at negative 3, 0. And the other one is at 1, 0. So we have this going on. Again, axis of symmetry for us visually is going to be halfway between the pair of points that we have at zeros. So we're going to have our axis of symmetry going right here, which I'm sketching on now, and I'm going to label x equals negative 1. Now, if you wanted to, we can actually find that value algebraically, in that the h value, the x component of our vertex, is equal to our s value plus our t value divided by 2. So in this case, s is going to be negative 3, t is going to be 1 divided by 2, That's going to give us negative 2 over 2, which gives us negative 1. So that is our h value, the x component of our vertex. Now to go get k is going to be equal to whatever our equation is equal to once we've substituted negative 1 into it. So our equation is y equals negative 2, x plus 3, x minus 1. Now we could use the standard form version all the way at the beginning. We could also equally use y equals negative 2x squared minus 4x plus 6. Either one of them should work, but let's use this one here because we're here. So we've got negative 2 and we substitute in negative 1 and negative 1. Now we simplify our brackets. That will give us a 2. This will give us a negative 2. And negative 2 times negative 2 is going to give us 8. So that is the y component of our vertex. Now just to prove this, because we're just hanging around, let's actually prove that the other one will work as well. So let's do y equals negative 2x squared. I think it was minus 4x plus 6. Minus 4x plus 6. Let's evaluate this one using negative 1 as well, just to prove that it'll work. So there's our negative 1 squared, negative 1, and our plus 6. So let's follow our bed massing here. We've got negative 2 times 1 plus 4 plus 6. That will give us negative 2 plus 10, which will give us 8. So we ended up with the same answer either way, which is nice. Our vertex then will be negative 1 and 8. So let's put that on the graph now. Negative 1 and 8. There it is. Whoops, that's not negative 1. There we go. Negative 1 and 8. So let's articulate our plot pattern now. Maybe we'll do that just down over here. So we've got our 1, our 4, and our 9. And recall that these are our vertical values when we go out 1 in either direction from our vertex, 2 in either direction from our vertex, or 3 in either direction from our vertex. These will be amplified by our a value. Our a value is going to be 2. So instead of going out 1 and down 1, we're going to go out 1 and down 1 times 2, which is 2. And instead of going out 2 and down 4, we go out 2 and down 4 times 2, which is 8. And instead of going out 3 and down 9, we're going to go out 3 and down 9 times 2, which is 18. So let's get this plotting happening. So there's our vertex, out 1 and down 2. Well, that's good. That corresponds to our y-intercept already. And then we go out 2 and down 8. And those happen to be our x-intercepts, which is nice. And then out 3 and down 18. These will actually fit on our graph as well, amazingly. There they are, and its partner all the way over here. So we have a really tall, narrow graph here. Let's sketch it in with some nice curved lines as best we can. There we go. Little wobbly, not too bad. Let's get some arrows on this thing. And now let's label. So we are going to label our x-intercepts. That's going to be 1 and 0. That's going to be negative 3 and 0. Let's label our y-intercept. That's going to be 0 and 6. And let's label our vertex. That's going to be negative 1 and 8. And we can label the equation itself. So y equals negative 2x squared minus 4x plus 6. Or you could label it with the factored form version. And there we go. So that is our first example worked through. Hopefully you're now beginning to see how all three forms of our quadratic have something to contribute to its graphing, and how you can move back and forth between the forms. We can go from standard to factored by factoring. We can go from standard all the way to vertex by completing the square. And we can go from either vertex or factored form to standard by multiplying out and simplifying. So that's the first example. The second half of this lesson, which will be in our second part, is about building an equation of a quadratic relation in factored form given particular pieces of information. So I'll see you in part 2.